Welcome back, chemistry fans. Got a homework assignment. This is Unit 6, Topic 3. This is about expanded octets. Let's jump right into it. All right, so here we go. You have two of these Lewis structures that we need to draw and then figure out what their shape of their, the name of their shape is to go along with it. So how do we know that these are expanded octets? That's the first thing. Why do you not just go ahead and put them into the regular want minus have formulas and figure it out? Well, the most important thing you will see is these fives. That means that there are 5 atoms on each of the molecules. You can't do that with the normal shapes that we have listed. This means there are 6 atoms. The tetrahedral was the biggest atom that we had with only 5. So this means these are expanded octets. So what I'm going to do is I'm going to draw both of these. I've got Br in the center, and then I have 3 Fs surrounding it. And it really does not matter how that you draw it. And so we would draw the exact same scenario for the Fs over here. I'm sorry, for the PF5 over here. And so we have 5 of those structures over here. Okay. Now, because want minus have does not work, what we're going to do next is we're just going to count how many valence electrons they have total. Well, in this first example, there are 6 atoms. They are all halogens. That means they all want 6 electrons. So that is 7 is how many they have. So they each have 7, but there are 6 of these. That is a total of 42. There are 5 atoms around it. They are each going to bond once. That is 10 electrons. That is a total of 32. So now if I then count up how many electrons there are to get ourselves to a stable octet, that would mean that each one of these external atoms is going to have 6 electrons around it. So if I complete that task, what that means that there are 6 times 6, that's 36. I'm sorry, there are 5. There are 5 that have 6. That is a total of 30, meaning that I have 2 left over. So that means that this bromine is going to have 2 extra electrons. Okay. Now, when you have 6 elements that have, or when you have 6 ligands bonding around this central atom, what that means is that it is going to be of the octahedral version. So that means I will have a central box, and then coming out of this box, I have 2 atoms going one up and one straight down. So it has a flat surface box, square, and then coming out of the top and coming out of the bottom are extra electrons. Now, because one of these coming straight up out of the top is actually just extra electrons, what we end up having is a structure that looks something like a square pyramid. And so that's the name of this shape, a square pyramid. Now, contrasting that over to the left side, PF5, you're saying, well, shouldn't it be the exact same? Well, no, it's not, because P has fewer electrons. So we're going to do the math the exact same way. And what we would end up with is I would have 5 atoms that each have 7. That's 35. And then I would have 1 atom, the phosphorus, that has 5 valence electrons. So that's a total of 40. Now, counting up how many electrons around each, again, there are 5 atoms and they each have 6 electrons to get a stable octet. So that is 6 times 5, which is 30, meaning that I have 10 extras. Well, there's 2, 4, 6, 8, 10. There are no extra electrons. So this does not have 6 ligands around it. In fact, what it has around it is just 5. So this shape looks like a flat triangle with a line going up and down. Now, where we had the extra electrons on the bromine coming out the top and bottom, on this one, the extra electrons actually come out of one of the, electrons in the center region here. So what we end up having is this shape that looks something like this. Well, what they actually end up calling this thing. 1, 2, 3, 4, 5. I'm missing one. 1, 2, 3, 4, 5. Oh, no, we do get to keep this one because there are no extra electrons. So what we get to call this one is a trigonal bipyramidal. Now, if I had lost one set of electrons, we would have had a seesaw, but this one is called trigonal bipyramidal. So we have two different additional shapes that we have to be able to adjust and draw their expanded octets for. Okay, this is everything that I wish to share with you. Thank you very much for your time. I will talk with you again soon. Bye.